All right, so we're going to try and graph this function here. So I don't have it written out on here, but I'm going to do everything in the same order that we've been doing it in. So that means the first thing I'm going to do is find my y-intercept. Right, and to find my y-intercept, that means I plug in, I find f of x, or f of 0, right? We can, f of x and y are the same thing. So this function is equal to f of x, because it's a function of x. So I plug in 0 for x. For my y-intercept, 2 times 0 cubed minus 0 squared, minus 8 times 0, plus 4, all over 3, times 0 squared, plus 10 times 0, plus 8. Okay, that's all going to cancel, except for the 4 and the 8, which is 1/2. So my y-intercept is going to be 0, 1/2, right? Remember, it's an ordered pair, so we have to write it that way. Next step would be to factor. Now, this numerator can only be factored by grouping. You may never have seen this before. It's definitely a skill you need in pre-calc. It's a learning target, but we'll just do it this way. You won't see anything like this on a test per se, but I can factor this, which means that we can use this as our example. So it's already in 4 terms, so we can factor by grouping, right? What can we pull out of here? We can pull out an x squared, and we're left with 2x minus 1. What can we pull out here? We can pull out a negative 4, and so we're left with 2x minus 1. Okay, so then that means that this factors into x squared minus 4 times 2x minus 1, but x squared minus 4, that's still a quadratic, right? It can be factored farther. It's actually a difference of squares. So this becomes x plus 2 times x minus 2 times 2x minus 1. So now I've factored the numerator completely, and I need to go ahead and try and factor the denominator. So the denominator is just, a pretty straightforward quadratic, 3x squared plus 10x plus 8. Okay, I ask myself what multiplies to 24x squared and adds to 10x, right? To get the 24x squared, I multiplied 8 and 3x squared together, and then the 10x is b. This is the AC method. Okay, so that's going to be pretty obviously 6x and 4x, and then actually now we do the factor by grouping anyway. So factor by grouping should be something you know. You've just maybe never seen it with a cubic. The 3x squared plus 6x plus 4x plus 8, right? Then factor by grouping, 3x leaves you with x plus 2. Take out 4, that leaves you with x plus 2. So this is going to factor to 3x plus 4 times x plus 2. Okay? Then we've got our function. So f of x equals x plus 2 times x minus 1. I don't know why I said minus 1. It's definitely supposed to be minus 2. 2x minus 1 all over 3x plus 4 times x plus 2. Now, notice that our x plus 2 is going to cancel, right? So really, our final factored form that we're going to use moving forward is x minus 2 times 2x minus 1 all over 3x plus 4. To find all the other components of our graph, we're going to use this new factored form. All right, so let's find our x-intercepts, vertical asymptotes. I don't remember which one comes first, but it doesn't really matter. So to find our x-intercepts, we set the numerator equal to 0. So x minus 2 and 2x minus 1 equal to 0. And that's going to give us x equals 2 and x equals 1/2, right? But keep in mind it's ordered pairs, so our x-intercepts are 2, 0, and 1/2, comma 0. Okay, and then we can try and find our vertical asymptotes. Remember, for the vertical asymptotes, we set the denominator equal to 0. So that's going to give us x equals -4/3. Okay, and then last but not least, we need to check for a horizontal or oblique asymptote, right? So we look at the degree of the numerator and the degree of the denominator. So we need to multiply this out real quick, right? F of x equals 2x squared over 3x plus 4, right? I don't actually have to multiply the entire thing together because I'm only worried about the highest degree. So because 2 is greater than 1 by a single degree, this is going to have an oblique asymptote, which means that we do need to do polynomial long division, and we do need to multiply this back out so that we know what to put on our polynomial long division. So 2x squared minus 4x minus x plus 2. So our polynomial long division is going to be 2x squared minus 5x plus 2, and then this is 3x plus 4. Okay, so this one asks us to take, well, it's just polynomial long division. So ask ourselves what multiplies, what do we have to multiply? The kind of question we're asking is what do we have to multiply 3x by to get 2x squared? That's what we're looking for. So obviously it's going to be an x. We need an x in there, but it's also going to be a 2/3, right? 3x times 2/3 x is going to equal 2x squared because the 3's cancel. So this will have a slope of 2/3. So 2/3 x, and then we have to multiply everything by 2/3. So 2/3 x times 3x leaves us with 2x squared, as we wanted. 2/3 x times 4 leaves us with a positive 8/3 x. And then there's nothing else, so we subtract that. And then we have to do -5 minus 8/3. Negative 15 over 3 minus 8 over 3 is going to be negative 23. X over 3, drop the 2. And then we just ask ourselves, what do I have to multiply the negative 23, or what do I have to multiply 3x by to get negative 23x to the third? So 3x times what gives us negative 23x to the third? Well, let's see. If we wanted to get rid of the 3, we would have to multiply by 1/3, and then we would multiply by negative 23/3 to get the rest. So it looks like we're going to have to multiply by negative 23/9. Okay, now normally, if I was giving this to you as a problem on a test or on the homework, it usually gives you a nice oblique asymptote, right? I spend a lot of time working backwards to make sure it's pretty nice. But, that's okay. If we actually know how to do polynomial long division, we should be fine. So what this tells me, again, I don't have to keep going, because all that, if I kept going, all that would give me is a remainder. And remember, the remainder does not matter. We don't care about it. We don't need to use it. So we don't do that. All we have to do is write it in y equals mx plus b form. Okay, so now that we have all of our components, let's go ahead and put them on a graph. Okay, so let's see what I can remember. Seems like I can remember nothing. So let's start with our y-intercept of 0, 1/2. 0, 1/2. That's going to be like right about there. And then I have x-intercepts at 2 and 1/2. So 2 and 1/2. And then I have a vertical asymptote at -4/3, which is just a little past one. And then we have to plot the oblique asymptote, which was y equals 2/3 x minus 23/9. Okay, and if we do 23/9 in our calculator, 23 divided by 9, it's, about 2.5, 2.55. So when we go to plot this oblique asymptote, it's really going to be, our y-intercept is -2.55. So it's going to hit, right about, not there, a little lower, right about there. Okay, and then its slope is up to over 3. So I would go, up 2 like that, over 3. So that's going to put my dot right there. I'm going to erase that. Okay, so I don't want to trace it because then I have to go through it. But again, that'd be up 2 and over 3. So my point's going to be right there. Up 2 over 3. I'm going to have a point right there. Okay, we can go the other direction as well. Down 2. This way 3. So I'll have a point right there. Down 2 over 3. Down 2 over 3. So that's going to be our oblique asymptote. Okay, again, oops, I completely missed the point there. Again, I did. We are only doing a sketch. So you can just sketch the oblique asymptote however you need to. But it's in y equals mx plus b form, right? If you know how to graph a line, which you should from like Algebra 1, then you should be fine here. All right, now that we have all this information, we need to make a sign chart. So let's go ahead and do that down here. And remember, along the first column is where we put our factors. So this is all we've got. This is what we use. X minus 2, 2x minus 1, and 3x plus 4. Those are my factors, I believe. Yes. And then along the bottom, in a number line fashion, from negative infinity to infinity, I'm going to put all of my x-intercepts and vertical asymptotes. So that would be -4/3, 1/2, and 2. Okay, right? We'll put our x-intercepts and our vertical asymptotes. So -4/3 would be first, then 1/2, and then 2. Okay, so let me draw some grid lines in so we can fill in our sign chart. So remember, all you do is on the intervals, you plug in points within that interval and you just see if it's positive or negative. So how about I will plug in -10. Well, -10 minus 2 is negative. -10 times 2 minus 1 is negative. -10 times 3 plus 4 is negative, right? It's always a good idea to pick like a bigger number or a more extreme number because it doesn't take much thought for me to say, oh yeah, 3 times -10 plus 4, that's definitely negative. But if I had plugged in like, I don't know, -3 or -2 or, -2, I might have had to really think, oh, okay, 3 times -2 is -6 plus 4. Okay, that's negative. So you're just trying to make this easy on yourself, which is why I'm going to plug in 0 for this interval because it's between -4/3 and 1/2. 0 minus 2 is negative. 0 minus 1 is negative. 0 plus 4 is positive. Then from 1/2 to 2, easiest option to plug in will be 1. 1 minus 2 is negative. 2 times 1 minus 1 is positive. 3 plus 4 is positive. Then here I'll plug in f of 10. 10 minus 2 is positive. 10 times 2 minus 1 is positive, and 30 plus 4 is positive. So now I can look and see on what intervals my function is above the x-axis or below, or if my function's positive or negative. So if I have an odd number of negatives, it's going to be negative. So that's going to be here and here, right? If you ever multiply an odd number of negatives together, it'll give you a negative. Then here I have 2 positive, here I have none positive. Okay, so now I know the intervals where my function is both above the x-axis and below it, right? And we can see that. Let's see, it starts negative. So let me just kind of draw that in as light as possible. You don't have to draw it in when you're doing these. There's no need to do that. I just do it because I think it shows you guys a little better of an idea of where the function is and what the sign chart means, but you don't have to do it. So the sign chart says the function is negative from negative infinity to negative 4/3, which means my function's going to be down here somewhere. Then from negative 4/3 to 1/2, my function is positive. So my function's up here. Then from 1/2 to 2, my function is negative. And then from 2 to infinity, my function is positive. So we have to keep in mind some things outside of the sign chart, right? Not only does our function have to follow the instructions of the sign chart, but it also has to follow the asymptotes. So we kind of did this in class, but I'm going to do this exercise again to kind of show you again what I mean. So, following this asymptote, my function can do one of two things. It can follow the asymptotes this way, or it can follow the asymptotes that way, right? And even if I could even, make this stay down here, right? So how do I decide which one it is? Well, it's got to be this curved one here. Okay, it can't be this guy. Because this guy, if you notice, it's got an arrow. Even though I didn't cross the x-axis, I didn't make it go positive, it's going up forever. It doesn't just stop. These are continuous functions. You can't just be like, okay, dead end, function's over, right? It'll eventually will go up and cross the x-axis, right? It can't go like that because, well, 1, it's no longer a function, but 2, there's no asymptote there that it's following. That's just making stuff up. So this guy right here, the one that I have left, has to be our function. It's our only option for what we can put in this little area. Okay, and then from negative 4/3 to 1/2, we have a little bit of help because we know we have to, oops, I was on eraser. We know we have to hit these 2 points, right? So that's a no-brainer. It's got to hit those 2 points. And we've got to follow this vertical asymptote in the positive direction. So this is really our only option. And then from 1/2 to 2, we don't have an asymptote to follow, but we do have to hit both of these points and be below the x-axis. So we can connect them like that. And then last but not least, from 2 to infinity, we are above the x-axis, and the only asymptote we have to follow is the oblique asymptote. Okay, now with oblique asymptotes, you can cross them, just like you can cross a horizontal asymptote, but you won't always, and you don't have to. It just happens sometimes. Okay? Oh, there's one thing we didn't do. I hope somebody was yelling at me for the last 20 minutes that I just blatantly ignored this. This would have helped us graph. We didn't need it, but I completely forgot to find my hole for x plus 2, right? There's a removable discontinuity at x plus 2 equals 0. So at x equals -2, we have a hole. So I have to plug in -2 to my function. So -2 minus 2 times 2 times -2 minus 1 all over 3 times -2 plus 4. That's going to be -4 times -5 over -6 plus 4, which is going to be 20 divided by -2, which is -10. Oops, -10. So I actually have a hole. I cannot believe that I just skipped over that. At -2, -10. I have a hole in my graph. So that would have helped us graph this. -2, -10. So I've got to kind of edit my little oblique asymptote here a little bit. That was a good enough sketch, but now that I have an actual point that it's equal to, right? It's undefined. It's an open circle at -2, -10, but now I know, oh, my function's going to look like that. So that helps me even more. Wow, I'm glad I caught that before I published the video. But there you go. I was so focused on the graphing part, I forgot about it.